The next mineral deposit that we're going to talk about is a kimberlite pipe. And I just wanted to say that kimberlite is an igneous rock. It's ultramafic, which means it's really dark. And it is the type of rock that we have to look in order to find these rare minerals called diamonds. Ultramafic or kimberlitic magmas, they form really far down, maybe about 150 kilometers down. And I like to think of the diamonds as being like hitchhikers. And so the kimberlitic magma decides to come up through the ground in a very rapid manner. And if diamonds are present, then the kimberlite magma will pick up the diamonds and bring them explosively to the surface. Now, typically you get these kimberlitic magmas underneath the foundations of continents, which we call cratons, or along subduction zones. It's important that you remember that diamond needs to form at a specific temperature and pressure condition. If the pressure and temperature is too high, then you won't get diamonds. If the pressure and temperature is too low, then you'll get graphite and not diamonds at all. So these kimberlites, they pick up the diamonds and they bring the diamonds to the surface. In this diagram, you will see the perfect sweet spot. So the sweet spot is right here where the pressure and temperature is perfect for diamond creation. Down here is where the kimberlite starts, and it moves up and it picks up the diamonds and it brings them all the way to the surface. If you were to look in this little area, you'll see that the kimberlite is expanding and it's the shape of a carrot. So over here on this side, we're seeing this little block in a blowed up fashion, and you'll see that the kimberlite is expanding, 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 and you can see the pipe is the shape of a carrot. And on the top, it's perfectly circular. We call it a little crater. And oftentimes what happens is the little crater is what gets weathered and eroded, and it often fills up with water, forming shallow lakes or shallow ponds. And so this is essentially what we're looking for when we fly over in helicopters looking for kimberlitic pipes, is we look for perfectly circular ponds that are filled with water. Then we go down and we can either go to the bottom of the pond or we could drain the pond, and we identify that the rock is kimberlite, and then we hope that there will be some diamonds in that kimberlite. It doesn't necessarily have to have diamonds, but it's a good probability that it might. The third type of deposit is hydrothermal, and hydrothermal basically stands for hot water. And hot water has the ability to dissolve away rocks and minerals and dissolve elements way better than cold water. So typically what you're going to need is you're going to need a magma chamber in the area, because the magma chamber forces its way up through the ground and cracks the ground. So you need cracks all around in the ground. And also the water, because it moves close to the magma, it actually gets heated. So the water is down there moving around, getting heated by the magma, dissolving away rocks and minerals and taking in all kinds of elements in solution. These hot water solutions go up through the cracks above the magma chamber, and as the water moves away through the cracks, it gradually cools down. As the water starts to lose its temperature, then obviously it can't dissolve the minerals as good anymore, so the minerals get crystallized out and fills the cracks full, and we call those then vein deposits. It is also possible that if the hot water solutions doesn't necessarily go into those cracks and forming veins, then it is possible to get some mineralization in a very speckled, spread out form all around the outside of the magma chamber, and we call those disseminated hydrothermal deposits. This is a really, really good diagram, and in this diagram I want you to focus on this little area. So you can see the magma chamber, and I'll put an M for magma. The magma has nothing to do with this because we are doing hydrothermal. This is not a magmatic deposit. However, we do need the magma just to warm the water and to crack the ground. So you can see the cracks in the ground here. So as the hot water comes up, it actually goes up through the cracks. Crystallization takes place, and the minerals fill those cracks, forming veins. And so you got these high concentration hydrothermal vein deposits. This area all the way down around here, and I always say to students, put hair on the magma chamber. Pretend you're putting hair on the magma chamber. Anywhere in this area it is possible to get some disseminated mineralization in that particular area. And the concentration of the hydrothermal deposits in this area would be lower, no doubt, but that is how you basically get hydrothermal disseminated versus hydrothermal vein. And you may have to identify that on a test question in class or on the public exam. So watch for hydrothermal veins and watch for areas where you would get hydrothermal disseminated. In terms of secondary enrichment, I'm not going to say a whole lot about this, but basically the mineralization is not enriched enough to be a deposit, but some secondary process has to take place in order to enrich it further. So I often say to students, imagine if you had soil and in that soil there was aluminum. We would need some type of secondary process to come along to do something to enrich that aluminum. So imagine if we had wind and the wind blew all of the soil away because the soil was so light. As a result, the aluminum in the remaining soil that was left over would be more concentrated. So we have a secondary process, wind, that's working to enrich the soil even more with aluminum. Also, another process that we could have would be leaching, where water would percolate down through the ground. And as the water percolates down through the ground, it would take away the soil and the nutrients and the particles. And basically, the aluminum would be left in a higher concentration in the top part of the soil. And so leaching is a secondary process, just like wind is a secondary process that can serve to enrich the mineralization even more. Bauxite is a mineral that you need to know in this course, and bauxite is a mineral that is predominantly mined for aluminum. So the leaching would take place mostly in like a tropical rainforest type environment, whereas the wind would probably take place more in a desert type environment.